Hello dear students, our today's lecture topic is the electric potential due to a uniformly charged thin spherical shell. So today we are talking about the potential due to a uniformly charged thin spherical shell. So here we are considering a thin spherical shell which is having a charge q on its surface. Clear? So now this let O be the center of the shell and capital R be the radius of the spherical shell. P is the point outside the shell where we have to calculate the potential due to this shell. So we know that the shell is carrying a charge q. So for first case, outside the shell we have to calculate the potential outside the shell. So this is the outside point, outside at surface, inside. So these are our 3 points where we have to calculate the potential due to the thin spherical shell. So for first case outside the shell, the electric field at point P is given by we all know that E is equal to kq by r square. So this is the electric field at point P, and we know that E is equal to minus d by dr. This is the relation between the electric field and the electric potential. So we move this dr to the left hand side. So we have dv is equal to minus E dr. Now we are putting the value of the electric field from the above equation to this. Then we have dv is equal to minus kq upon my r square dr. What is k is here? K is 1 upon my 4 pi epsilon naught. Now integrating both sides, then we have integration dv is equal to minus kq because it is not depending upon the dr. So it comes out integration dr upon my r square. Now so as we put the formula for the integration, so this become the capital V, which is the total potential of the shell at point P, is equal to minus kq. Now we are applying the simple integration formula x की power n dx. So we have bracket r minus 2 plus 1 upon 2 minus 1. So in denominator we left minus 1 and in numerator we left r की power minus 1. So this minus cancel out each other and we left with the positive sign. And we know that this is r की power minus 1. We can write it as 1 upon r. So the electrostatic potential due to a thin spherical shell at point P is given by V is equal to kq upon r. So V is equal to kq upon r. This is the value of the electrostatic potential at point P which is outside the shell. ठीक है? So V is equal to 1 upon 4 pi epsilon naught q by r. So this is our potential outside the shell. Clear? Now here we have another case, second case, at the surface of the shell. So we are considering our point P at the surface of the shell. In that case our r, small r, is equal to capital R. So we just replace it. So V is equal to kq upon capital R. So this is the value of the electrostatic potential due to a thin spherical shell at the surface of the thin spherical shell. So now we have our third case, which is a very important case, inside the spherical shell. As we all know that inside the spherical shell, the value of the electric field is 0 because the charge inside the shell is 0. But the potential is not 0 inside the shell. How? We know that E is equal to minus d by dr. So dv comes out to be minus E dr. We know that the value of the E is 0 inside the shell. So our V comes out to be 0. 0 means constant. So we have constant value of our electrostatic potential inside the shell. So please remember this third point, which means that for a spherical shell the electric field inside the shell is 0 but the electrostatic potential is not 0 because it is constant inside the shell. Clear? Now This is the graphical representation of the electrostatic potential V with respect to R. Clear? As we know that up to from center to the capital R, the radius of this spherical shell, the value of the electrostatic potential is constant. So we represent it by a straight line. So we draw a straight line from center to R, means center to surface, or O to R. Clear? Now beyond this, the potential varies inversely proportional to the R. So V varies according to 1 upon my R, which is inversely proportional. So it keeps going decreasing till 0. Clear? So that's all for the today's topic, or for the lecture, for this lecture. So please remember these points. Outside the cell, the value of the potential is V is equal to 1 upon 4 pi epsilon naught Q upon R. At the surface of the shell, the value is V is equal to KQ upon R, or is equal to 1 upon 4 pi epsilon naught Q upon R, capital R. Inside the cell, electric field is 0, but electric potential is constant. Okay, this is the graphical representation. Thank you.